Hi guys, Mr. Johnny here, and this video is sponsored by Mess on a Bench, and it presents this. This is a mess, isn't it? Now this thing is a 2-transistor switch mode power supply, and before I get into it, I want to put this kind of safety first kind of deal. If you're not familiar with electronics, working with mains fed circuits, high voltage stuff, do not try to reproduce this, especially in this way. If you're just a beginner, please take your time and learn from smaller, simpler, safer circuits. I'm not trying to insult you. I was a beginner myself, and I am glad that I started with simpler circuits. Then I gained some experience which now allows me to make this and stay alive. Alright? So start from simpler stuff and you will eventually be able to create this, or much better. So, schematic. Schematic for it looks like this. Alright. Where's the pencil? Where's the freaking pencil? Here it is. The core that I've used is about 23 square millimeters worth of cross section. It has about 0.3 millimeter gap in total. That means a 0.15 millimeter thick sheet of paper between the two halves of the core will do. And yeah, the output of this supply is about 9 volts, and it can output half an amp easily, and it will do that at and it will be about more than 60% efficient doing that. This supply is awesome in comparison to one transistor circuit because for a number of reasons. First reason, it has current limiting, so it doesn't afraid short circuit. The transistor actually stays cold when you short circuit. When you apply dead short circuit like this pencil on the output, like slam it, this pencil is an aluminum by the way, you slam dead short it doesn't care. The transistor will run cooler than it does supplying 2 watts on the output. Amazing, at least for me. Another advantage that it runs without load just fine. It will not blow up, which is amazing again. And it runs at about 1 watt without no low consumption, which is a lot, but I don't plan to leave it all plugged in for all the time, so it's not a problem for me. Alright, now the original circuit is a circuit that I saw in Danik's video, and that was a re-engineered circuit from a cheap Chinese charger, like this kind of deal. You know that. We all know that. Designed in California by Pepple or something like that. With weird pronunciation errors and stuff like that. Now that circuit looks much more like this. The difference is that this one has no snubber and my circuit does. And what good is adding the snubber in? The purpose of the snubber is to take the spikes from the leakage inductance and dissipate them on here, on its resistor, rather than on here. Because if you don't have snubber, just like cheap Chinese circuits do, all those spikes gonna end up on across this transistor, and they will make it run hot. And that's no fun. I would rather have a resistor running hot in the circuit than a transistor running hot in the circuit. Resistors are made to dissipate power. They're made to resist. And when they resist, they dissipate power. That's their job. The job of the transistor is not to dissipate power. Its job is to switch. So again, I would rather have a snubber getting hot than a transistor getting hot. Alright, so you see the number of turns yourself. I told you about the core. let's show you that it does work indeed. I'm using my watt meter because this way I see the consumption from the mains, and during development I actually saw it running away, and I was able to pull the plug out before it catched flames. So the watt meter is definitely a great tool to have. Okay, so this meter is connected to watt meter and displays watts from the mains. Drawn from the mains, this meter is an amps through the load, which is these two bulbs. 12 volts they are, and 5 watts each, but I run them at 9 volts, so at 9 volts it will be about 5 watts, about 5.3 watts, as you will see. Okay, let's and it's indeed powered from that. See the cable right there, going through the ballast to prevent nasty explosions, because because of the rat's nest. It's very easy to short out something and catch some parts in your face. Okay, hopefully you can see it. Watts from the mains, amps through the load. Plug it in. Alright, we see about 0.58 amps. Damn fridge. It starts only when I try to shoot a video. Freaking reciprocating pump. Alright, and this meter is... this meter doesn't really fit, does it? You see, I have no regards for safety. Don't be like that. No. By the way, this circuit is not isolated from the mains. I don't run isolation transformers. I am a careless F, if you will. 9.17 times 0.58, very close, so I can say that. It is 5.3 watts, as I mentioned, and it consumes 8.1 watts. Let's say 8.2 watts, alright? See? About 65% efficient. Amazing, isn't it? And since I run this circuit not isolated, I can only touch the parts to see whether they are hot or not when I unplug it. I see the plug here, and I can touch the parts now. Transistor is warm, but not hot. This resistor is hot, but as you can see, I can hold my finger on it. Partially because this room is cold, big Clive kind of temperatures. So yeah, everything runs cold here because the room is cold. And I run cold too. That's why my voice may get all bassy, slow, and babbling again. Alright, so you saw everything you need. You saw the schematic, but I didn't show you the no load consumption, did I? Here's the load. I'm gonna switch it off, and as you can see, about 1 watt. And I connect it. It's still powered. And I can short circuit it, look at the amperage, and look at the consumption. 1.5 amps and 2.6 watts. See? I can connect the load and I can short it out. See, it's very nice. Right now it is limited to about 5 watts and it cannot supply more. The main limiting factor here is the transformer itself, because the transformer here is a coupled inductor, really, and it can store only the given amount of energy and no more. And this happens to be able to provide 5.3 watts with ease, but not more. I guess 6 watts tops. Okay. Did I mention everything? Alright, I'm gonna leave it up to you. If you have any questions, leave them in the comments below. Thanks for watching, see ya.